Fine, I will start again. So what you see in the blue dotted line is the differential amplifier, right? And this is able to amplify the difference between terminal number 3 and terminal number 2. Okay, these are voltage gains. Okay, and we also have a circuit called level shifter, which is not discussed just for the sake of simplification. And then this cyan, the block, this is the push-pull amplifier, right? So basically this is a circuit, and this circuit is divided into blocks. So that's why we study about the block diagram. Okay, I hope this is clear to you. So as I said, we have two modes of operation. One is called differential mode of operation, and other is called the common mode of operation. Okay, in the differential mode, now just try to memorize the symbol of op-amp, right? In the differential mode, either one signal is amplified to an input with the other input grounded, or two opposite polarity signals are applied. For example, consider this. This here, what we see is that there is a signal, source of signal connected to inverting terminal. Okay, minus means inverting terminal. So a source of signal is connected to inverting terminal, whereas the non-inverting terminal or the plus is grounded. In the second case, we have signal source connected to non-inverting terminal or the plus terminal, and the minus one is grounded, right? This is called single-ended, because of course that here we have a signal V in, whereas here we consider that this is 0. Similarly here we consider 0. So the output will be amplified based on the difference. What is the difference? The difference is 0 minus V in here, and difference is V in minus 0 here. So again we have a difference of the input signal, right? But only one end is connected to the source, that is called single-ended. When an op-amp is operated in single-ended differential mode, one input is grounded and the signal voltage is applied to the other input. Whereas in the double-ended differential mode, two opposite polarity, that is out of phase signals, are applied to the inputs, right? For example, see this. See, what is the meaning of out of phase? It means that we have the signal out, we have two signals. One is a sine wave, so it is starting from the positive half cycle and going to the negative half cycle. Whereas on the other hand, we have sine wave, but it is going through the negative half cycle first and then the positive half cycle. So they are having opposite polarity, and such signals are called out of phase, because they are having 180-degree phase difference between the two, right? So they are called out of phase signals. So these out of phase signals are applied to the inputs, and the difference, amplified difference between the two inputs, it appears on the output. For example, this is simplified by this. For example, we have plus here and minus here, let us say. So the plus is connected to minus and minus is connected to plus here, right? Anyway, we are going to have the difference between these two. right? So this can be effectively represented by the second. Both are same, right? So the amplified difference between the two inputs, it appears on the output, right? In the common mode, two signal voltages of same phase, frequency and amplitude are applied to two inputs. So he see here, both signals are same, and then they are given to both the terminals plus and minus. So if both the signals are same, that means the difference should be 0, right? Difference should be 0. And if you amplify 0, no matter how much, with how much value you multiply 0, the output is still 0, right? So in the common mode, two signal voltages of same phase, frequency and amplitude, they are applied to two inputs. And when equal input signals are applied, they tend to cancel each other, resulting in a zero output voltage. This action is called common mode rejection, right? Now, how this may help? For example, we have a noise appearing at nearby the circuit. So most of the times it happens that we have put a circuit and then there is a nearby power line or of 50 hertz. Now this 50 hertz line will introduce a noise in the circuit. Now if this happens, then there will be a noise of 50 hertz, right? Now the noise must be cancelled. As we have discussed earlier, the noise is an undesirable signal and it should never appear in the output, right? So what will happen? Noise is something which will be common to both the terminals, right? It cannot happen that the noise is something different at plus and something different at minus, because if you look at the actual circuit configuration, then see, this is number 2 and this is non-inverting terminal third number and this is inverting terminal second number. Now if external noise is affecting, then it will affect here and here in the same way, right? It may not happen that they will affect two in a different way. It is going to affect both of them, and if they affect, if it affects both of them, then they will cancel out each other, and if they cancel out each other, the output will be output of the noise will be 0. So this is called common mode rejection, right? And it is good actually, right? Now again we have a pole